afternoon. Hello, world. All right, if I can have your attention, please. We have quite a number of vocabulary words to give you today. And Artists Rejoice will be doing some drawings today. Ladies, with me, please. You had like 5 minutes. I'll wait, and that will just eat into your lecture work time Thursday and Friday.
Miss, do you have paper?
Line paper? There might be some in the closet. All right, we ready? You ready? Go ahead and walk it over to the trash can if you don't mind, please, Mr. Theo. Thank you. All right, make sure that you have one of these tools, as we'll be using it to draw straight lines. We'll be using it to measure 90-degree angles, and we will be using it to measure things today. Here we go. It's over here, sweetheart. You got on your jacket? Okay.
Did I really?
Yeah. Oh my goodness. There you go. This is the same lesson as yesterday, so please do not skip a page. If you want, you do not, Diego, over here, thank you. You do not have to rewrite the title or the objectives.
It's the same thing.
It's the same thing. We are just continuing. We are going to pretend that today is just continuing from yesterday, okay?
In the same page?
The same page if you still have room. All right. Here we go. Yesterday's session was all about the special segments you can create in triangles, okay? The median, the altitude, the perpendicular bisector. Today, we're going to talk about what happens when we draw more than one of these in a triangle and we look at where they intersect. But before we can talk about that, we've got a couple of fancy new words to give you. You ready? The first of these fancy new words to give you is concurrent lines. Say that 3 times fast. Oh, nice. Concurrent lines are 3 or more lines intersecting at a common point.
Yes, so what if it was just 3 lines like that and then one in the middle?
Okay, that would be concurrent lines. Is this just in your pencil?
They need a journal.
Yeah, okay, perfect.
Let me see if they need it.
Okay. All right, thank you, ma'am. The next fancy new word that you need before we can start talking about these special points.
Are we going to be drawing today too?
We are going to be drawing some data today too, yes.
Yeah.
Is the thank you. Is the point of concurrency. This is the point where those lines intersect, those concurrent lines. So the point of concurrency is the point where concurrent lines intersect. Let's do our drawing so we can figure out what these look like. Okay, get your straight edge and draw a line. Any line you want. I need a name for this line, a single letter, please. I heard T. T. All right, so we're going to do a T. Please make sure that this is a lowercase cursive letter. Yes, there will be another cursive handwriting. Yeah, I'm out. Another cursive handwriting item coming out very soon. So, Miss Padilla, I have a photocopy. Okay. Yeah, this is the first page. All right, let's draw another line. Take your straight edge. Draw another line.
Miss, how many pages are we doing today?
It's been 2 so far. Give me another name.
B.
L, I heard first. Remember, lowercase and cursive. All right. Now, the third line needs to intersect at that same spot to make these concurrent lines. So I'm going to make sure I put my pen on that point of concurrency before I draw my line. Oh, I missed. Try again. Okay, there we go. Ignore the first one. I'm going to use this one instead. All right, name for this one, go.
A.
I heard N first. Again, lowercase and cursive. This point right here is the point of concurrency. It needs a name. Go. I heard G.
V.
I heard G. I heard G. So we can say that lines L, T, and N are concurrent, and their point of concurrency is G. Okay? All right. Let's go and work on the first special point that we run into with our triangles. And this point is the circumcenter. The circumcenter of a triangle is the point of concurrency of the perpendicular bisectors of that triangle. Time for art. Take your straight edge and draw a triangle. Any triangle you want. Acute, obtuse, isosceles, scalene, right? It don't matter. Just draw yourself a triangle right here in this space. Go, do it now. Do it. Draw a triangle. There's my triangle. Do. They shouldn't be in because the impression it makes. Please, please. We'll wait.
I can hear you.
No, I understand, but still, we need to have it away so we can focus on this. Thank you. Okay, we need to find the perpendicular bisector. This is the line that goes through the midpoint and it hits at a 90 degrees to this side, to every side of the triangle. So I'm going to start with this side first, and this is where our ruler comes in handy. So I'm going to measure it out. This one looks like it's, I don't know, 8.2 centimeters, 8.3 centimeters. So I'm going to take half of that. Well, half of 8 is 4. Half of 2 is 1. So 4 and a little bit more. So 4 and a little bit more. That's about the midpoint of that side. Repeat for all the other sides. If you don't have a ruler on your protractor, just guess where the midpoint is and draw it there. Okay? All right. I'm going to guess on mine. Here. And I'm totally guessing right now. There. Okay, I have made my guesses. That's where I think my midpoints are, because I handed my ruler off to be used, and that's okay. So there's my midpoints. All right, getting a straight edge here. Now I need these lines to be perpendicular. I need them to be at right angles. Okay? If you have your protractor, this is what you can do. Do you see this line right here next to the vertex finder? That's your 90-degree mark. So if you set that against the side of your triangle and make sure that your edge of your protractor butts up against your pen when you put it on the midpoint, this line is the perpendicular bisector. Repeat for all of the sides of your triangles. Now, if you don't have a protractor, here's what you can do. Get any sheet of paper, and the corner is 90 degrees. Okay? Here's my clear sheet of paper, this little box. And you're going to line up one edge of your paper to the side of the triangle, and you're going to slide it until the corner hits that midpoint mark that you made. And then you're going to trace the edge of the paper. Now, depending on what kind of triangle you drew, the intersection is either going to be inside the triangle or outside of the triangle or somewhere on the line of the triangle, and it's okay. You let it be wherever it's going to be. Okay? What you're trying to do is get a point of concurrency. I had to try to remember the word. You're trying to find a point of concurrency, a point where all three of these lines you're going to draw are going to meet. Okay? So do that now. Okay? Do that to all three sides. Thank you. Oh, I don't like sneezing. Oh. Okay, I'm trying very hard to make sure this is exactly 90. Okay, look, mine's not going to do it. Can you see?
Yep.
I missed. We want it to be there, okay? So what this means is if this happens to you and you're drawing in pencil, clean it up, erase, and make sure that these marks are 1 in the middle and 2 that those lines are exactly perpendicular, okay? If you can get both of those things to happen, that point, you'll end up with a point of concurrency. I'm writing in pen, I can't fix it, so I'm just going to make it so that it connects for my notes. Okay, but it's supposed to work, so double check it. Make sure that it does. If it didn't, erase the one that you suspect might be off and fix it again. Make sure that you find the exact middle of your side and make sure that the line you draw through that is exactly 90 degrees to the side. If you can get both of those, it will work every single time. Okay, I'll give you guys just a few moments. I'm putting in my congruence markings to show that these are supposed to be perpendicular and congruent. And this right here is our circumcenter. All right. So far, so good? This is okay? Yeah? The drawing might be a little weird, yes? Okay. And let it. The drawings aren't going to be perfect. This is like the 20th time I've drawn these triangles today because there's like 4 of them in each lesson. Yeah, so I've drawn a lot, and I still don't get them right, as you could see. But this definition, this vocabulary word, is going to give us our first theorem for the day. And it is very creatively called the Circumcenter Theorem. I know, right? Creative names, us mathematicians. Here's what this says, and what I'm going to do is I'm only going to write in this very narrow band here on the left, so I can use all the rest of the space for my drawing. Okay? The Circumcenter Theorem says this. It says the circumcenter of a triangle is equidistant to the vertices of the triangle. So draw your triangle, find your circumcenter, and then let's look at which segments are going to end up congruent because of this theorem. Okay? So if you didn't, you don't feel like you drew the circumcenter beautifully the first time, don't worry about it. Here's your second chance. I have the rest of the paper, so I'm going to go ahead and draw my triangle just as big as I can manage.
Yeah.
You know, YOLO, right? There's my triangle. Wow, this one's really pretty. This triangle came out like really even looking. Okay, and I'm going to measure each of my sides.
Cricket.
Mine's crooked? Oh, yours is crooked. That's okay. Crooked triangles are still good triangles. Looks like an oval. Use straight edge, bro. Okay, so a little more than 3.5. And now I'm going to measure this side. Yeah, I'm going to do this way. This one's going to be a little more than 3.25. And this one is going to be just less than 3.5. All right, so that's where I think my middle points are. Again, when you're doing these, you want to grab your ruler and you want to try to be as precise as you can. Okay, now I'm going to take either my right angulotron, which is the corner of my piece of paper, or my protractor, and I'm going to get 90 degrees to that side. Okay, there's one perpendicular bisector. Here's another perpendicular bisector. Here's another perpendicular bisector. Oh, look. Dude, mine totally hit in the same spot. Look. I got a point of concurrency. Finally. Yes. All right, how did you do? You got it? Woo, high five.
Yeah, that might.
You got yours. Air high five. Did you get yours?
Yeah.
No? Try again.
No, I failed.
You failed. Try again. No big deal. Try again. Try it again.
You know what? I'm just gonna say ish.
No? Try again.
I'm just gonna say ish.
You're going to say ish. You know what? High five. Air high five. Over here. You got it right on? Air high five. There you go. You get it?
Try it again.
Más o menos. Okay. Air high five. Keith? Ish. Air high five. Perfect. All right. Here's what the theorem says. Here's what the theorem says. It says this point right here, that circumcenter, if you were to take a segment and connect it to the vertex, this segment would have the same measurements as every other segment going from that same point to the vertex of the triangle. Notice how the green lines that I'm drawing don't match up with the perpendicular bisector lines that I had done before. You know, they're different. Okay? They're probably different on yours as well when you go through and take your straight edge and connect those. You can see the kind of math problems that I'd come up with this word, right? If this point D is the circumcenter of a triangle, and this distance is 4, then what's this distance? 4, yeah. Okay, those are the kinds of things that I could ask. The only way I could make it more complicated is if I threw some algebra in there and asked you to solve for a value of x. Okay? That would be the only way I could make it any more complicated than this. All right? All right, let's go on to the next special point in a triangle. I'm out of room on that page, so I need to change pages. If you are also out of room, do change the page with me. If you still have, 6 lines or so, you should be good to continue. Yeah. All right. The next special point that we have in our triangles is the centroid. Do y'all watch Star Wars?
Yeah.
This is the centroid. You are. Huh? You don't like it? I'm sorry. All right. The centroid is. Okay. Ladies, I can hear the conversation. It's definitely standing on topic, but just turn the volume down a little bit, please. Thank you. The centroid is the point of concurrency of the medians of a triangle. So now we're going to draw our figure. Draw a triangle. Go back to yesterday's notes to look at what a median is. You'll find that a median is going to go from vertex to midpoint. There's going to be 3 of them. Draw all 3. Okay, here we go. I'm going to draw my triangle. It doesn't matter what triangle you draw. If you've drawn a bunch of acute triangles, change it up. Try an obtuse triangle. See what happens. Try a right triangle. See what that looks like. Because I don't know. I haven't done them with all of them yet. Because I don't know. I just start drawing triangles and stuff happens. All right. I need midpoints. Again, I'm going to use my ruler.
D. J. B.
Whoa. Thank you for names.
Yeah.
Not going to use them right now. Thank you, though. I'm sorry. I'm sorry. I'm not going to use them right now. I'm sorry. Don't hate me. This looks like it's 2.8 maybe. You know what? YOLO. That looks about half. That looks about half. That looks about half. I don't know. I'm just going for it.
Yes.
All right, but these are medians. We don't care about perpendicular anymore. We just want to connect this point to this point. Whoa. All right. Repeat for all the other sides. Median.
Bless you.
And median. I was a little off on this one. Yeah. Thank you. I will do it again. I'll keep drawing them. Thank you. We'll share it. Try to remember to put it here. Okay? This is going to lead us to our final theorem of the day. We have this one theorem, and then we have one more special point, and we're done. The name of this theorem is the very imaginative Centroid Theorem. This is where the stormtroopers go up to Darth Vader and explain why those weren't the centroids that they were looking for. Nothing? Man, no, I guess not. Yep, tough crowd. I'm getting nothing. I gotta change my material. You're up. Oh, break my heart. All right. Here's what the centroid theorem says. And once again, I'm going to limit my writing to kind of this narrow band right here to leave space on the right for my drawing. The centroid theorem says this. The centroid of a triangle is 2/3 of the distance from vertex to midpoint. Go ahead and draw your triangle. Find your centroid. And then we'll grab one point name, and I'll try to make a better joke than Star Wars for you guys. Okay.
B.
All right.
B. Second person is D. D.
Okay. I'm trying to find the centroid right now, so I'm doing this without a ruler. I'm just kind of guessing where the middle point is. Okay. Yes, yes, yes.
Got it.
And then because these are medians, I'm connecting them to my vertex. And I'm doing that for each one. Oh, snap. It's perfect.
Yeah.
Awesome. I did it. All right. I had heard that they wanted a V here.
D.
And I already have names for this because it's part of my joke. If I put those points, those are part of my joke. I just needed the middle one. All right. Here's my joke, okay? Okay, it's a story. My joke is a story. Ready? All right. All right, here we go. So you're having a birthday party. Sorry.
She's gonna fart to sleep.
I don't mind waiting. It's your time. All right, so you're having a birthday party, and you want Jay-Z to come and rap at your party. Okay? You want him to come by and rap. But, dude, there's no way. Like, there's no way. He doesn't even follow you on Twitter. How is he going to, like, no, he's not going to come by. So what you're going to do is you're going to find these two other guys. You're going to find this rapper JV and this other rapper VZ, and they're going to come by and they're going to rap. But what you got to do is you got to make sure that you're going to get, like, the same kind of qualities you get from Jay-Z coming by to rap, right? Okay? So you got to make sure that this rapper JV, that his, yeah, it's really lame, I know. It's 2/3, he's 2/3 as good as Jay-Z, right? That's all, okay, he's not a good rapper, but I mean, he's still 2/3. He's almost half as good as, he's more than half as good as Jay-Z, right? That's pretty good, right? So you got to make sure this other guy, this Vato Z man, he's a Spanish rapper. If he's only 1/3 as good as Jay-Z, man, you put them two together, it comes out just as Jay-Z. Can you see the kind of word problem questions I could ask for you from this kind of thing? Más o menos.
That was a weird.
It was kind of weird, I know. All right? Okay. All right, here's our final point. We've got a lot of conversation happening in the back, and it sounds like it's starting to go off topic. So pull it back into special points of triangles, please. Thank you very much. Here is our final point. The final special point in a triangle that we're going to be studying today is called the orthocenter. Yeah, math and these funny names. It is. It is. Math is weird. Orthocenter. Okay, here's what the orthocenter is. The orthocenter is the point of concurrency of the altitudes of the triangle. Not the attitudes of a triangle. The altitudes of a triangle. Let's draw your diagram. Draw a triangle and draw the 3 altitudes. Remember, go back a page into yesterday's notes. Look at what the altitudes are. Looking back at yesterday's, the altitudes are those lines that come from a vertex and go toward the opposite side. And it doesn't matter if it hits it or not, but it has to get there at a 90-degree angle. Okay? So here we go. I'm going to draw my triangle. There's my triangle. Okay? I don't care about midpoints now. All right? All I care about are perpendicular lines. So I'm going to put my pen on my vertex. Going to mash my protractor up against it, and then I'm going to swing my protractor around side to side until I land on a 90 degrees. And then I'm going to draw my line. That's an altitude. Repeat for the other 2 vertices. Oh, my protractor moved.
Got it.
You got it? Perfect. Right on?
Yeah.
Nice. High five. Ready? Oh, mine's gonna miss. Okay, I'm gonna make mine hit just because I really want it to. This point right here, that is the orthocenter. Bless you. General questions on any of the vocabulary words that we saw here today?
Nope.
We're doing good?
Yeah.
All right, thanks.